students, I am Nilanjana Sanyal. Welcome you all to my channel Linus Online Math Classes. Our today's topic is some restrictions of logarithms. This is part 1. Today in our today's session we will be taking up the first restriction, and in part 2 that will be our next video session. Over there we will be taking up the second restriction. Okay. So without any further delay, let us start with our today's session. What is the restriction that we have on logarithms? The base of a logarithm cannot be a negative number. It cannot be equal to 0 or it cannot be equal to 1. Why can't we take the base as a negative number 0 or 1? Let us know that. Okay. Let us start with the very rightmost number, that is 1. Let us take the base of the logarithm to be equal to 1. So let log 2 to the base 1 equal to x. And we convert this to an exponential equation. So this is the base is 1, this is the argument which will become the answer for the exponential form. The argument is 2 and this is the product or result which is x. This will become the power in the exponential form, because for log form we have the BAP, and when changed to exponential form it becomes BPA, right? So changing to exponential form we have 1 raised to the power of x equal to 2. 1 is the base remains the base. The product or result becomes the power and the argument becomes the answer. So it is 1 raised to the power of x equal to 2, and we know that whatever may be the power of 1, it remains equal to 1. The answer is always equal to 1, no matter what is the power, what is the value of the power of 1. Okay. So you cannot have this type of an equation. This is not a valid equation. 1 raised to any power is equal to 1 and not 2. Therefore, you cannot have 1 as the base of the logarithm, of any logarithm. You can say that we can have log of 1 to the base 1. This is equal to 1 if we have this type of an equation. And if we change this to its corresponding exponential form, this is the base is 1, this is the product or result which becomes the power. It will be 1 raised to the power of 1, and this is the argument which will become the answer. So it will be 1 raised to the power of 1 is equal to 1. Definitely this is a special case. In fact, you will be seeing log of 1 to whatever base you take is equal to 0, because if we have log of 1 to the base x equal to 0, that makes sense, because if we convert it to an exponential equation, it will be x to the power of 0 equal to 1. And we know that any number raised to the power of 0 is equal to 1. So you'll be seeing that log 1 to any base is equal to 0. This is the special case if you have log of 1 to the base 1 equal to 1 and you change it to its exponential form, it becomes 1 raised to the power of 1 equal to 1. But do you really need such an equation? I don't think so. Okay. So we do not take the base of a logarithm as 1. The base of a logarithm cannot be equal to 1. Now let us take up this number 0. So case 2 is let log 5 to the base 0 equal to x. Again we will be changing it to this equation to its corresponding exponential form. It will be 0 raised to the power of x equal to 5, and this is also an invalid equation because 0 raised to any power is equal to 0 and not equal to any other number. So this is also an invalid equation. Therefore, we cannot have 0 as the base of a logarithm or logarithmic term. Coming to the third case, a negative number as the base of a logarithm. Over here you are having log y to the base of negative 2, and in this case I have taken a specific value, I have taken it as half, because I could have taken it as x like the previous two cases. Actually, this can be very easily proved using the property of changing of base rule of logarithms. But we haven't come to any properties of logarithms. So I am not being able to use that rule or that property of logarithm in order to prove this. So I have just taken up a special case. For the timing, you just remember that negative numbers cannot be taken up as base to be the base of any logarithmic term. This is one of the cases. I have just taken up one of the cases, one of the problems that may arise if we have a negative number as the base of a logarithmic term. So if we have this type of an equation and if we convert this to an exponential equation, what happens? Negative 2 is the base, y is the argument, which will become the result of the exponential equation, and half is the product or result for the logarithmic equation, which will become the power of the exponential equation. So it will be negative 2 raised to the power of half is equal to y. And we cannot have a negative number, negative 2 raised to the power of half. If we write this in third form, what happens? It is square root of negative 2 equal to y, and square root of a negative number is not a real number. We cannot have a negative number under the square root. So this is one of the problems that arise if we have a negative number as the base of a logarithm. The general case can be very easily proved using the changing of base property, but since we have not learned that property till now, in fact we have not learned any of the properties of logarithm till now, so I have shown you this special case. This is one of the reasons why you cannot have a negative number as the base of a logarithm. Okay? So students, this brings us to the end of this session. Please like, share and subscribe if you find this video helpful. Thank you for watching this video till the end. We meet again very soon. Till then, bye.